In this video, we're going to do one more example of balancing a net ionic equation. This one's a little different in the sense that you don't have to, the double replacement reaction's already been written, and as you can see, the AQs and the S's, so all of those have already been filled in for you. So it makes it a little bit easier as far as just go ahead and getting started on this one. But you could go and double check to make sure that this is actually aqueous according to your solubility rules. This is aqueous, this one is actually insoluble, and this one is aqueous. But we'll make it a little easier because they are there. Okay, so when you have your double replacement reaction already written out and you've got your states of matter already in, the next thing that you have to do is you have to separate your species that actually do dissolve in water, your aqueous ones, into their respective ions. So if we look here, we'll go ahead and separate lead nitrate. So we'll go ahead and put Pb. And we know that in this case, lead is a transition metal, so sometimes it changes its oxidation number. But we know in this particular case that lead is going to take a positive 2 charge. The way that we know that is because we have to look at what it's combined with. It's combined with NO3, which is nitrate. It's a polyatomic ion. This polyatomic ion has a charge of -1. It always has a charge of -1, and that never changes. But there are two of them. So I have two -1s. So the total charge for the two nitrates is a -2. But I only have one atom of lead. So that one atom of lead must be must be a +2 to cancel out the -2 on the two nitrates. So we'll go ahead and continue here. So that is aqueous, and we'll add our nitrate, so NO3, and we already said it's a -1 charge, and that is aqueous. Now I know in the formula I've got a 2 here, but I don't really worry about putting the 2 here because I'm just interested in the charges or the ions that they form in this step. The balancing, we'll make sure that that works out later on. So after we've done this, we go to our next aqueous, which is H2SO4. That's actually sulfuric acid, but you can say hydrogen sulfate. So the H2, we know that hydrogen has a +1 charge, and it is also aqueous. So even though there's a 2 with this, we don't worry about putting the 2 here, because once again, we're just worried about the charges in this step. So sulfate, we're going to add sulfate, so plus SO4. Sulfate is a polyatomic ion with a -2 charge, and that is aqueous also. So now we're at our arrow, so I'll go ahead and put the arrow here. So now, like before, I'm kind of running out of room, so I'm going to continue on at the bottom, but what I'm going to write down here really should be on the right-hand side of this arrow. So we've come to PbSO4, so lead sulfate, but they already told us in the problem that this was insoluble, which is denoted by this S, which stands for solid. So let me do a different color for the right-hand side of the equation. Let's choose orange. So I'm going to go ahead and just write that out. So it's PbSO4, and I'm going to put the solid on it. Okay, so this is exactly what's up here. It doesn't separate like the ions in red because it doesn't dissolve. It's a solid. So the next one we're going to dissolve this, the hydrogen nitrate. This is actually nitric acid, but you can say hydrogen nitrate. I think that's fine too. So it's going to dissociate or basically ionize, if you will, into H+1, and that is aqueous. That's in water. And then we're going to have our nitrate, which is NO3, and the charge on nitrate is -1, and that is also aqueous. So now, like we said before, this is kind of the hard part. Once you get to this part, the rest is just canceling out and writing out what you have left. So I want to go through and I want to cancel out some things. So I'm going to start here with the Pb+2. I have lead +2 on the left, but I look over here, on the right, there's no Pb+2 on the right. So I'm going to skip and go to the next one, which is the nitrate -1. there is a NO3 negative 1 on the left, and there also is a NO3 negative 1 on the right. So I can cross this one and this one out. These are spectator ions because one is on the left and the same thing is on the right. So basically the nitrate is not really doing anything in this reaction, so that's why they're called spectator ions. So the next one we go to is the H plus 1. There is a H plus 1 on the left-hand side of the equation. There is a H plus 1 on the right-hand side of the equation. So once again, I can cross this one out, I can cross that one out. And these are spectator ions also. So now, look at SO4, and the SO4 negative 2, there's only one of them. There's not another one that shows up on the right-hand side. So now I just need to write what I have left. So let's scroll down so I can have a little more room. And so we'll try this teal color. Alright, so we've got PB plus 2, and we know that that's aqueous. So we'll put that there. That comes just from here, from up here. I'm just writing down what I've not canceled out. So it's PB plus 2 plus the next thing in the list is SO4 negative 2. So SO4 negative 2, and that is aqueous. And then I'm at my arrow, which is the yields. So what's on the next hand side is PB SO4, and that is solid. So I can double check. Let's make sure this is balanced. I have one lead on the left. I have one lead on the right. So leads are balanced. I have one sulfate. You can look at this individually as sulfur and oxygen, but it's kind of useful to think about this as a complete polyatomic ion. I have one SO4 on the left. I have a SO4 on the right. So that's fine. Another thing that you can do is double check your charges. PbSO4, there is no charge here, so basically the effective charge is 0. So if I look over on the left-hand side, a positive 2 on the lead plus a negative 2 charge on the sulfate equals 0, which is what the charge on the lead sulfate on the right-hand side would be. So this is the balanced net ionic equation for this particular example, and this is called the precipitate because it comes out of solution, it is not soluble, and it is a solid. So there's the precipitate.